So it's a very long press. It's going to be a kind of long presentation. But if I ask Gemini that what is the most difficult top 10 passes in X-ray, and this is third rank, memory, what was it? I forgot the exact term, but SPMD partitioner pass is the most difficult. The second is fusion, and the third is like kind of memory layout related pass will be the third difficult pass. So, and also the source line also like 2000 line for this, and unit test is also very complex and very long. But yeah, I try to cover the philosophies about copy insertion pass as much as possible in this article so that you can understand code very easily after this presentation. So yeah, and it's going to take for me, like it took me like 6 to 8 hours just write this article. So I hope to help you understand this pass. So copy insertion pass is a very important pass in the X-ray compiler between memory optimization and stability. So in this, what I mean by memory optimization is like X-ray try to use in place as much as possible, which means it try to reuse memory as much as possible. But sometimes if you in place operation so many, then sometimes because of the scheduler, some operation is executed first before or if the computation is not what we expect, then sometimes the memory is corrupted. That's why the output is also can be incorrect. Yeah, I try to explain examples one by one, but yeah, main goal is like to try use in-place operation as many as possible, but at the same time, I wanna correct output. That's what copy insertion pass is done to, and this pass is the last pass of the entire pass. This is the last pass. So the process will be performed in these 3 steps. First, it tries to add copy conservatively. It tries to add copy as many as possible for the save output. And then it tries to remove copy, redundant copy with as a separate step. Then lastly, it tried to handle the special cases. This is the 4th step. And I have a entire part 4 and part 1 is about why do we need. This is the part 1 is mostly about why do we need, and part 2 is about how we add this copy instruction conservatively for these 4 cases. And then third is how do we remove the copy, and the last step is like then what is the special cases. That's the flow of this article. So for example, let's take a look at the Swiss-link case in a while loop. For example, if your while loop has 2 loop states with size 2 tuple, one is A and B, and the loop body trying to do is like it tried to swap this loop state AB to BA, and if you keep doing this, AB becomes BA, BA becomes AB, or something like that. And the problem here is like, so when you override in1 to in0 position, and then at the time of writing override in0 value with the in1, the in0 value will be gone, right? And then if you don't care about the computation order, and if this operation will be done first, then the entire memory will be in1 and in1. If you don't care, if you are not careful about the operation computation. So in order to make sure that the output is correct, output correctly, you need to copy. First, you need to copy in0 to some safe buffer and in1 to safe buffer. And then for output buffer, you need to copy the correct location to with a safe buffer kind of. And then you also need to make a dependency between these two. For example, copy in1 should be performed before this, right? That's why control predecessor will be attached that copy in1 should be executed before this. Also, this one also had a control successors. So after this one should be executed. So yeah, this is one example to add like copy conservatively. And in this case, this is the correct, or this is the not redundant copy cases. This copy should be added for exact output.
Actually, there is redundant copy, right? You don't need to copy one.
This one?
You don't, that's the second copy.
This
That is
one?
not one.
Ah.
So I mean, it's conservative, so I guess it's fine. I mean, it will be removed, right?
That's a very good question, but I didn't check whether this copy is removed or not. I didn't check. But let's see, copy in1. I think this can be removed according to the theory before, because copy in1 is maybe not. So later you try to apply kind of sandwich theory. So if you have a value is defined here and the final use is here, and then lifetime of the copy in1 is from here to there, and if there's no instruction.
But copy out 0 is used, right? So
no, it only takes care of this value.
Okay.
Because the buffer, so it only takes buffer into consideration. The buffer lifetime is from here to there, and if this buffer is not collided with the other instruction, in computation or otherwise, is used only in that range specifically, then that can be removed.
Then what about copy in 0?
Copy in 0?
What is the conflict in copy in 0?
Copy in 0 is that here, it's used here. And that's a good question. I also think about this too. Okay, I think about that too later. Thank you for a good question. And the second case is like conditional branch buffer aliasing. So conditional operation can take two computations, which is true branch and first branch. And this is fine because if you just look at the true branch case, it's fine because anyway, buffer for negation is different from the buffer of parameter. And this can be writable, it's fine. The problem is like this pass-through case. So this first branch, it return parameter buffer, which is read-only. And if the conditional branch is executed as a true case, then our first case, the buffer for condition is like buffer for parameter. And we are going to write buffer for conditioner, and this will be violate the rule that buffer for parameter is read-only. So if it's executed for first case, then this will be read-only buffer can be overwritten.
Which buffer is overwritten?
Buffer for P, yeah.
In the case of true? I mean, in the case of false, or which one?
Why my explanation and here is different. Right? I think this is when it is true, this buffer will be returned, right?
Okay.
And the buffer parameter should be read only.
Okay.
And if you write read only buffer, that's very dangerous case.
What I have a question. Like, what is the negate function here?
Mhm.
I mean, in the comments, with the like function inside of the main,
Mhm.
so there's a comment that, which is so result of negate could overwrite the original buffer of P.
Mhm.
So then, what is the negate in the comment? I mean, there's no negate if you go to the true branch.
And let's revert. So branch true is okay. So branch true is executed, and you're going to write negation of something in some buffer location, and this buffer location will be shared by first and true branch. So branch first also return a value. Branch true also return a value which is conditional, and this also has a specific buffer location. And if true is, yeah, I
I
think
think from reading the above paragraph, it says like, so if negate executes,
Mhm.
the cond will have separate buffer, right?
Mhm.
Cond will be like out of place. And if
Yes,
the
yes.
false branch executes, cond will have same buffer as the original P, right?
Yes, yes.
So depending on the condition, the buffer is different. So it will cause like some side effect because of that. So the original P can be overwritten or not depending on the condition, right? The buffer of original P.
Oh,
So in the false case, the buffer will be same. In the true case, it will be separate buffer.
yes, yes, yes.
So depending on the condition, the buffer is different. So it may cause, so you can't actually predict if it's going to be in place or out of place. The resulting buffer is in place or out of place. So the following operations can cause side effects.
That's also true. Also, the problem, that's also true. The problem is like the buffer for parameter should.
So that's why it says like it will add copy in the false case, right? So it will copy so that the resulting buffer is always out of place.
Thank you. I think that explanation explains better. Thank you. So as a first step, you try to add a copy instruction, and every computation returns condition have this conservative copy operation. And later, it's also, if it is redundant, for example, for all of the instruction is maybe then pass through or overwritten, then could be copy can be removed, because if our guess is correct, then if the both sides has an in place or both sides has an out of place, then it's going to be removed. I'm not sure about that, but according to our agreement, then that is going to be true. Okay, the third is
there is slight inconsistency here. So above, actually, we assume the negate is out of place. So I don't know why we need actually copying the true case.
This case is conservatively added.
Yeah, but if it's root instruction, then it's obviously out of place, right? So
But in this case, it don't.
So you can just add copy to just for both branch.
First branch only.
I mean, yeah, why do you need
This one?
copy for, yeah?
Ah, yeah, because it's now doing as a conservatively. And after that, copy remover, I'm not sure that whether it is removed, copy remover handle this. If we think that this is redundant, it's going to be removed.
so actually copy is just inserted for every operation, right? In
Now
conservative
for
case.
every operation, but we're going to handle it the third. If you have a this conditional select, if you have a conditional branch or select branch, which means you have a two buffers, right? One value is a two buffer. In that case, yeah, conservatively adding copy.
Okay.
Only in that case we add a copy.
Yeah, this is the second case of the conservative add. There are while loop case, conditional case, send receive case, and replace case. Also, and there are another case that, so for example, if you're going to send something, and while the receiving data, or while sending, there are two cases, while sending data, while receiving data. While sending data, if data is overwritten with another operation, also there could be a dangerous case. In this case, the copy is instruct here. Before send, we need a copy, and then there's another, not only these, we're going to also add a contract predecessors and contract successors to make sure that this order should be strictly kept. And also, this is only about send instruction, but for receiving also, after receiving, you need to also copy the content, kind of. And this is only done if I'm also going to handle the case later, but if the GKX or X-ray because it has a kind of right to generate code, so it knows the kind of pattern. So if the certain pattern is met, then it tries to add a copy instruction or something like that. But if the pattern is not matched what it expects, then it tries to skip because it doesn't know this pattern, and maybe this is written by the another order. There will be like intention, so it doesn't touch. Also, another case is like in place operation. For example, dynamic update slides, or maybe FFT in our cases, or something like that. So, and this is the case that what we have right now when we have a scatter, when the scatter operation is expanded. So, for example, we're going to add this add instruction for loop induction variable, and dynamic update slides will be update the loop state into the loop state. The problem is so the P0 and use is two different value, and if this is executed first than this, then it's fine. But if this is executed before this, then the problem is P0 is not the value that we expect. So the order is very important in that case. So in that case, we're going to have a copy before this. No, copy. We're going to have a copy after this and before this. So before doing anything, P0 will be copied first, and this one going to use the copy of the P0 and copy of P0.
Then it's gonna be wrong, right?
Copy of P0. Let's see.
Yeah, it does.
Sorry. For T0.
Then still it's gonna be. Okay, it's gonna be fine. Okay.
Well, this is, I think, one case of this, and we're going to add copy here too.
Right. Copy which one?
Copy before making a tuple.
Copy which one?
Copy, use and use.
Because it's conservatively, I think.
Yes. So it's a copy of tuple then. So it's going to copy the input, right? Maybe this is not a while, maybe. So if you see the while case, before invoking while instruction, the init condition is copied too, and in the root body, this parameter is copied, and before returning, the last line also is copied. So there are 3 copies will be added. And the last 2 cases about special cases. So in this case, so there's a condition like if corner boundary, if it's entry function is corner function. In corner function, if you return true, all the buffers should be separated, isolated. But if you look at this tuple has a 2 value inside and 2 value kind of duplicated buffer, same share buffer. So you need to separate the buffer to make sure that every value inside the tuple has a different buffer. This is one of the special case, and this is going to handle after copy remover. Last one is this case. So also if it's an entry function or corner boundary, read-only, the parameter and constant or is treated as a read-only. And if you try to return this as a pass-through, then it's also going to have a problem. Yeah, if you want to make your corner function in place, then you need to add an attribute called input-output alias with a corner function or with the entry function. Then it's going to be in place. Otherwise, the buffer for output and buffer for input is same. Should be different. So in that case, all of them are copied and return have a different buffer.
Tuple also should be copied.
Sorry?
Tuple also should be copied, or no?
No, tuple doesn't have a distinct buffer. Tuple always have share buffer. Tuple and get tuple element, even though they have a different value, but buffer is always same. Tuple and get tuple element. So in this case, tuple doesn't have a distinct buffer.
Yeah, but above you said like, can you go above? Like maybe this case you said the below case. Yeah, I think this case maybe you said you do.
Value inside the tuple have a different buffer.
So you should said maybe in the above one you said in one of the cases you said like tuple should be copied as well.
Yeah, this one. So tuple actually doesn't have a buffer, but tuple shares buffer inside, which negate and negate and negate.
Yeah, this one, yeah, I get it.
So now it has a different buffer inside. Negate has a different buffer. Copy has also its own buffer. So these two are special cases. So case 5 and case 6 will be handled at the last step. So now at part 3, so we want to handle case 1, 2, 3, and 4. How it as like copy conservatively, and then we're going to see copy remover later. So if you in part 2, so there are 4 subpart. One is while loop, conditioner, send and receiver, and then the general in place. So it first checks which loop variables are at a risk with the indices to copy for while. And after this, if should copy is on, and copy will be added. So when we need to add a copy, so first case is like if you look at the code, if your while body has a inside receiver handle, or if you have a receive result in your loop state, and you shouldn't copy because there are two. Anyway, the first reason is like receive is always carries handle of the receiver. For example, like if you use the socket handle is the kind of file descriptor or any kind of handle is inside this value, and you can copy this handle just by copying memory. That's one reason. Yeah, and the second reason, like, if you have a pair of sender receiver, if you don't care about the matching the pair sender receiver, if you just copy receive in a different way, then this is going to wait for the another device or another party to send data, right? That's why it becomes the state will be hanged. That's why if you have a receive handle inside your parameter, then it doesn't try copy at the conservatively copy instruction. That's the one case. Second case is like ambiguous. If the value is ambiguity, and then it's trying to copy. And what I mean by ambiguity is like it means if your value have a after data flow analysis, if the value set size of your instruction is more than 1, which typically true for select or conditioner, then it tries to copy. And this is the kind of this guys. So it has like 2 kind of branches, and it can be, so one can be like in place, the other can be out of place. Then as we mentioned earlier, that could have a side effect. In that case, copy will be added constantly, kind of. So after analysis, select can have a value 1 and value 2. In that case, value set the size will be more than 1. In that case, we say it's ambiguous because it has a 2 value depending on the condition. And the third is like the value can be modified. Is the thing. If the value was modified inside the loop body, like error, negation, whatever, then we conservatively add. And then you can imagine it. Which case that the value is not modified. In the case that, so you invoke data flow that get unique value at init, and data flow that get unique value y or return if the value is same. For example, if you let's see the pass-through case. In that case, the value of the init and value of y person p is same, right? Then unique value of p and unique value of y is same. In that case, copy is not added. But if you have something like this, if you are unique value at parameter and unique value at y bar is different, in that case, copy is added before this. 예. 잠시 멈췄다가 이을게요.